This series is dedicated to steering behaviors. I think we've covered them in the past, but this one is updated for Godot 3.1 and up, and it's hopefully of a much higher quality. I'm going to guide you through the process, showing you how to make first an AI follow a point where you click with the mouse. Second, we're going to make it arrive to the point, make it smoothly slow down, because you can see that the previous behavior was a bit sharp. And then I will show you how to make several AIs follow a leader, follow one another using the arrive to behavior. Something you can use to make a party in an RPG, so you can make the characters smoothly follow the leader, those kinds of things. Without further ado, let's get started in this video with the follow behavior. Here is how steering works. So you have your character on one side and the target position on the other side. The target moves, right? The mouse cursor can move. So as it does, you want to adjust the player's speed to point to the target. As the character has a limited velocity, maybe every frame it's going to have a motion like that. But now let's say that the target was there on the previous frame, so the character was moving like that. We move the mouse cursor progressively and it ends here. Our follow steering behavior is going to do this. It's going to calculate the desired velocity, something like that. It's the direction to the target limited by the maximum speed. So let's say that the maximum speed allows you to move like that, roughly in one frame. It's a bit fast, but let's say that that's what you get. The follow steering is going to calculate a vector from the player's current velocity to the target velocity. So it does the difference of the two vectors, giving you a vector that points directly towards that. Okay, I'm going to make it red. And then we divide it by the mass. So we're going to make it smaller. We add the red vector to the current velocity, making the current velocity go like that on one frame. And so you repeat that every frame, making the vector slowly go towards the target more and more. And this is what gives you that smooth motion. That is for the follow behavior, the simplest one. To get started, you can find a start project in our Godot Engine Tutorial Demos repository in the description below. Head to the 2019 folder and you will find the demo in the steering follow arrive subfolder. There you want to load the start version into Godot. Link in the description below. I tend to use the command line as I'm a bit of a nerd. You can use Godot from the command line if you have it available there. And so here is the start project. It's going to open a game scene that has 3 circles, 3 static body 2Ds. They have some collision layer set that we're going to use in a moment. A parallax background to have a nice effect later when we'll add the camera in part 3. And if you go check the project settings, the input map, I've created a click input action for us so that we can detect left click easily from our code. This template will help us focus on the steering behaviors and our little AI here. We are going to create the first triangle that will follow the mouse cursor around. So go to Scene, New Scene, and we are going to not create a 2D scene, but use Custom Node here. Look for Kinematic Body 2D so that our triangle can interact with the world, can hit and detect the circles in our game scene. We're going to rename it to character follow, or it could be a follow agent, call it however you prefer. We're going to drag the red triangle in there. Go ahead and click and drag the file here. Note that all the sprites for the game are in the assets folder. I'll rename it to use Pascal case as it becomes a sprite, an object, and reset the transform. So in the inspector here, you want to click, that allows you to reset the value to 0. So our triangle is centered. To work, to collide with the world, a kinematic body 2D needs a collision shape. So let us add it. Control A, look for collision shape 2D. In the inspector, we're going to set the shape property to a new circle shape 2D. Then you can zoom in a bit on the view. Let me bring in the keyboard shortcuts here. I'm going to put them at the bottom. Zoom in with the plus key, or equal, but it's the key where you have the plus button, and click and drag on the point here to increase the size of the circle. Now select your red triangle, press W to toggle the move tool, and click Shift and drag to constrain the node to a single axis, and I'm moving it on the x-axis right there. Then Q key to select the selection tool, the one at the top left of the toolbar. We are going to select the collision shape 2D, increase its size just a little bit. There you go. This is our base scene for now. We are going to save it, Control S, and go in the source folder where we put all our source code. Scenes are part of your game source code. Right click and create a new folder. We're going to call it Agents. Agents for AI agents. It's a common expression in games in the industry. And save it as characterfollow.tscn. With that, we can quickly create a script in the same folder. Select the character follow node, click the script plus icon in the top right corner of the scene tree, and let's create a script. We want to set the template to empty and click create to create it. Okay. From there, we can start coding our character. So we don't have the steering function to make our character follow the mouse cursor just yet. We're going to do some setup to have everything in place so that we can add the follow part at the end. First, we want to have a reference to our sprite, to the triangle red here from the script, so we can rotate it. For that, you create an onReady variable. OnReady is like creating a ready function, like so, and having some code in there. It's syntactic sugar to save you a bit of time. And we are going to get our triangle red node. The $sign is a shorthand for get node. So we can use the $sign here. And it's of type sprite, as this node is a sprite. Then we want our character to move at a maximum speed, right? So the maximum speed is going to be 500 pixels per second. I'm exporting the variable so that when you go back to the scene and select character follow, you can tweak that value, or a designer in your team can do that in the inspector. With that, we need our character to have some velocity. The velocity is a vector that represents both the speed and direction at which the character is going to move. And our steering function is going to manipulate that, or it's going to calculate a new velocity that we will store in this variable. We will be able to move our character with that. So from there, we're going to create our physics process function. Because it's a kinematic body 2D, we want to use physics process to move it reliably. Now, our character is going to move to a target point, to a target position. So the first thing we'll create is a variable called target global position. It's going to be the mouse's position. And to get it, you can call the get mouse global position. While using a global position, because if we were to use get mouse position, it would give us the mouse position relative to the node. So if the mouse was here, it would give us a vector like so, but if the mouse is here, will give us a vector relative to the character, like so. As the character moves with local coordinates, you're going to shorten that vector. And using our follow function, it's not going to be a problem. You wouldn't get a bug in the movement. But as we move to other steering behaviors like arrive to, the distance to the target starts to matter. So for consistency, we're going to use global position when working with steering functions, always. All right, so we have a global position to move to. From there, we are going to move the character based on the velocity at the end of our physics process here. So using move and slide, we're going to pass our velocity variable here. And in between, we need to calculate that velocity. Okay, we're going to do velocity equals something. I'm going to do that for now, have just that template code, and we're going to code our first steering function. Steering are really reusable behaviors that you can use for all kinds of things. You can move elements and make them follow, arrive to a certain position, avoid obstacles and all that using vector calculations. For reusable code like that, you generally want to have some reusable library, something you can access everywhere in your game. Godot has a mechanism for that called Autoload. Autoloads are nodes or scripts that you can load in your entire project in the project settings. So let us create a new script, F3 to go back to the script editor, file, new script, and we are going to save it, like the path. You want to go to source. I recommend creating a folder called Autoload, and you're going to enter it and name it steering here and create our empty script. It has to extend node. This is very important. And from there, you can go to project, project settings, Autoload, select the path to the script that you want to load globally in the project, source folder, Autoload, steering.gd, press enter and click add to add it. From there, anywhere in your code, you can call steering like so and access it. So steering dot whatever. For now, it can't do much. Okay, so we're gonna go back to our vector2 here, and on the steering.gd script, we're going to add our follow function. We're going to create a static function for that. So let's create a new static function called follow. It's going to calculate a new velocity based on the follow steering behavior. As our velocities are vector2s in a 2D game, it's going to return a vector2. This is what in the optional type GD script, this arrow followed by a type means. It's the return type of the function. We can calculate a new velocity. That's going to be a vector2 and return our new velocity. Okay, so we have the base for the function. Before we add the calculations, we need a few elements, a few default values. So we're going to create a few constants up there. Because steerings work that way, you need some maximum speed that you are going to use to limit your new velocity, and you want to have some mass that you use to slow down the acceleration of the character. You're not using an acceleration towards a point. Instead, you will divide the steering velocity by the mass. Let's create a default mass constant. Let's set it to, let's say, 2. And we can duplicate the line with Control B to create a default max speed. We are going to use these in the function parameters. By the way, if you don't know what a static function is, it's a function that doesn't have access to the state of a class. It can only take values in here in the parentheses, and it's going to return a new value. Okay, it can't directly modify objects if you want. Press enter. We have a few parameters to put in there, so we are going to put each of them on a separate line. So the line of the function doesn't become too long, and they stay easy to read. First, we have the velocity, the input velocity, the speed at which the character is moving, if you want. Next, we're going to have the current global position of that character or object or agent. Then we need a target position. So we are going to use that to calculate a desired velocity. It's at the max speed. By the way, we have to change that to something bigger. This desired velocity is going to be the vector pointing from the character, the agent that it has to move, going as fast as possible towards the target position. Then we are going to have a max speed value that's going to be equal to our default max speed. And finally, we will have a mass equal to the default mass. Note that you have a comma after each parameter, but not the last one, because it's the last one. If you get an error there, if you have a stray comma because you duplicate the line, you have to remove that. From there, we can add the calculations. So we're first going to calculate our desired velocity. Okay. Let's create a new variable called desired velocity, and it's going to be equal to a vector pointing from the agent's current position to its target. You are going to subtract the global position parameter to target position. We turn it into a direction. We normalize the vector so it has a length of 1 and multiply it by max speed. This is what I said. This is the agent going as fast as it can, so it's limited by its maximum speed, towards the target. Then we are going to calculate a steering. The steering is going to be a vector going from the character's current velocity to the tip of the desired velocity. The difference between the desired velocity and the velocity, and we have to divide it by the mass. So desired velocity minus velocity here, divided by our mass parameter. That's why mass is going to slow down the character's movement. As you increase it, that steering vector becomes shorter, making the change in the velocity smaller and smaller. So we can remove our new velocity variable. A new velocity is going to be velocity plus the steering. So the steering is going to slowly steer towards the desired velocity here. It's going to make the velocity progressively, frame after frame, move towards the desired velocity. Because on every frame, the target can change position, you will see that the character will smoothly adjust to the target. We can save and go back to our character follow script. Our velocity is going to use the follow function on our steering autoload. And we have to pass in all the parameters. So first, the velocity, the current velocity. Next, we need the global position of this agent, the target global position, the target position of the enemy of the mouse in our case. And note that you can use, if you have the two scripts opened, you can use Alt left arrow to go back to the steering script so that you can see these parameters, and Alt right arrow to go forward in the history so that you can jump back to your character follow script. Next up, we're going to pass the max speed, and for now, we're going to leave the mass at default. All right, so with that, move and slide is going to use our velocity. One last thing we have to do is when you call move and slide, the character, when it's going to hit some obstacle, move and slide is going to return a new velocity that it slides against the collider that you hit. So you can control click on the move and slide function to read the documentation, but that you can see it returns a vector2, right? When you have that before a method name, it's its return type. and you will have in the documentation at the bottom, returns the linear velocity vector rotated and or scaled if a slight collision occurred. And then you can get more information in another method. But it's basically if you hit a circle in our project, it's going to try to make the character smoothly slide against it. Okay, so we have to assign that resulting velocity to our velocity variable. I'm going to remove the lines here. We have to go back to the game scene. And you want to add your new character to it. So look for character follow, click and drag it into the scene under the game node, and we can place it somewhere in the middle of the screen, let's say. Press F5 to try the game, and now you will see the arrow follows your mouse cursor. It does that weird thing, jiggling when it reaches the mouse. This is because it's trying to follow the current position and it's overshooting it. So we have to fix that. Another issue is that it passes through the circles. It doesn't detect them, so we have to set its collisions. And lastly, the arrow is not rotating as it follows the mouse. But you can see how it smoothly steers towards the mouse. It does not rotate abruptly. And this is what the steering behaviors and vector calculations give you. So let's fix these small issues. Go back to character follow. First, for the collisions, select the kinematic body 2D. You want to go to the collision tab under physics body 2D, right here. You want to change the layer. So I've named them for you in this project. The player has to be on the player layer and has to collide not with player, but with the world, the layer on which I put our circles. If you go to the circles, you can see that right here. They are on layer 2. This solves the first problem. The second is the character jittering around the mouse position. It's because it's constantly trying to move in physics process. So we want to add a condition. If it's very close to the mouse cursor, we're going to stop it. So let's add a new constant up there. We're going to call it distance threshold. It's going to be a threshold under which we're not going to move the character. If it's less than 3 pixels away from the mouse cursor, we are not going to move the character in this case. After we stored the target global position, we're going to add a new condition here. If the character is too close to the mouse, so if the distance from the character's global position, so you can do global position dot distance to. Note that this global position is a vector2, so distance to is a method from the vector2 class, and the distance to another vector2 to another point, target global position, is lower than the distance threshold. We return from physics process. Now we can test the game, and you can see that now if the character is on the mouse, it's going to stop. That is the second bug fixed. And the last one has to do with rotating the sprite. And that is fairly easy. We can do it like that. After the last line, we're going to take our sprite that we stored in a variable at the top of the script. So the sprite property that references triangle red. We're going to do sprite dot rotation. Its rotation in radians will be velocity dot angle. Angle is there again a method from the vector2 class. And anytime you can control click on a method to see its documentation here in the vector2 class, and it returns the vector's angle relative to the x-axis in radians. Going back to character follow, there we go. If you do that, the arrow will now follow your mouse cursor. Now, the character is really going abruptly, always at a constant speed towards the mouse cursor. In the next video, we will see how to make it smoothly arrive to the mouse cursor using the arrive to behavior. See you there. This is it for this first video, but there are 3 more to come, so I invite you to subscribe to the channel and hit that notification bell if you want to know when they come out, or just if you want to get more Godot, game creation and programming tutorials in general. From the next part, it's going to get a lot more interesting. We're going to look at the arrive to behavior, which is what we use for our hooking mechanic in our Metroidvania game project. You can find a link to that in the description box below. But for now, I want to thank you kindly for watching until the end. Be creative, have fun, and we'll see one another in the next one. Bye bye.